Let's continue talking about atoms, and now I want to talk about how big are atoms. So in order to do this, I'd like for you to watch this little video here, see Powers of 10 video on YouTube. So the music on it is kind of funky because this particular video was made in the 1970s, but it's still really, really good. And so what it's going to do is it's going to start off with a person who is laying on a blanket in the middle of Chicago, and the camera is going to be located 1 meter away from the person. Okay, then the camera is going to start backing off, and the numbers are going to go from being 1 meter to 10 meters to 100 meters to 1,000 meters, and it's going to keep going back and back and back until finally you're going to see clusters of galaxies. And then it's going to reverse itself, and it's going to start coming back onto the Earth, back onto the guy, and then it's going to start zooming in on his hand. And it's going to get to 1/10 of a millimeter, 1/10 of a meter, 1/100th of a meter, 1/1000th of a meter, and it's going to get all the way into the hand until you're going to see the individual atoms that makes up his hand. Okay, so I want you to watch that video. I'll wait. Okay, did you watch it? I hope you did. So it's pretty cool. And the picture that is, so the size of the atom is going to be 10 to the -10th meters in diameter. So to give you an idea for what that means, imagine you take a meter stick, and you were to chop it up into 1,000 pieces. Then those little pieces, those would be the millimeters. Now imagine taking a millimeter and chopping it up into 1,000 pieces, and then taking one of those things and chopping it up into 1,000 pieces, and then take one of those things and chop it up into 10 pieces. Then each of those little tiny pieces would be the size of an atom. You can actually visualize atoms. You can't visualize them using a conventional microscope that you might find in biology that uses light, but you can see them by using what's referred to as an electron microscope. And so that picture that is off there to the right shows individual atoms in a particular substance. And if you look carefully about it, what do you notice? You should notice that those atoms are making a particular pattern, the same way that molecules make a particular pattern when they make up a quartz crystal. So the way that atoms hook together is in a specific kind of way. And then finally, the picture there that is on the bottom again shows you how small things are in nature, and then it finally shows you how small the atom is. And so for purposes of the exam, you need to know atoms are small. Okay, that they're so small that you can't see them with your conventional biology microscope that uses visible light. Okay, some other things, this is very important, is what is the atom composed of? So an atom has a nucleus where protons and neutrons live. And then in orbit around the nucleus are going to be the electrons. Now depending on the element, you have different numbers of protons in the nucleus, and then you have different numbers of electrons that are in orbit around it. Okay, you should also notice the charge on the electron is negative. Make sure and know that. The charge on the proton is positive, and then the neutron is electrically neutral. Now, a fallacy, though, about atoms is that the electrons, which are in orbit around the nucleus, are like little planets. So if you think about our solar system, it has a star, the sun, and then the Earth and the other planets are in orbit around it, and they have specific orbits. Well, that is not true about atoms. So the traditional way of visualizing an atom is the picture there on the top, where it makes it look like the electrons have certain orbits around the nucleus. Well, a better way of thinking about it is a beehive. So here you have a picture of a beehive, and it's got these bees that are swarming all around it, and so it's very difficult to know where a particular bee is located at. It's even worse with electrons. So we know that the electrons are going to be located a certain distance away from the nucleus within a certain percentage. So we would say that with 90% confidence, we could say that that electron is located such and such meters away from the nucleus. But we don't know exactly where it's at because of this quantum mechanics. It's a way of understanding how very, very small objects work, and we're going to be using the results of quantum mechanics quite often in this course. Okay, so the point is, you don't exactly know where the electron is at any particular moment, and so what we do is we make these probabilistic guesses as to where the electron is located at. Okay, what about the relative size of the particles inside the nucleus and the electrons? So if you imagine a bowling ball and a bowling ball and then a ping pong ball. So the two bowling balls are roughly, they are approximately 2,000 times heavier than what that little ping pong ball is. And so similarly, both the proton and the neutron are about 2,000 times heavier than what the electron is. So that means most of the mass in the atom is located in its nucleus. Okay, then what is the mass of a typical atom? So the mass of a carbon atom is 2 times 10 to the negative 23rd grams. So that's 0.000000, about 23 zeros and then a 2. And then the mass of 1 gram is the same as a paperclip. So that tells me that the mass of a typical atom is very, very small. That's what you need to know. So don't worry about the number associated with it. But let's say that I said to you on the exam, grab an atom with your tweezers. You can't, but let's just say you can. So grab it with your tweezers, take it to the chemistry department, put it on their best scale, and what would happen? Nothing. Okay, so you cannot weigh a single atom using the kinds of scales that they have in the typical chemistry department. So that's what I would want you to be able to tell me. Now what's interesting is that in chemistry, they don't weigh individual atoms. They weigh lots of atoms at the same time. So they pick up thousands, millions, billions of atoms at once, and then they put them on their scale. So now don't worry about this being on the test, but chemists measure chemical substances in moles. And 1 mole is equal to approximately 6 times 10 to the 23rd atoms of something. And notice the mass of an atom is 2 times 10 to the negative 23rd. So that means that if you have this many of carbon, now you can actually measure its mass by using a scale. Are you excited about this? I am. Can't you tell? Okay. So let's take a break. When we come back, we're going to talk about what force holds the atom together.